often become busy living our life that we don't bother to question strange observations. There's a reason why the light travels in a straight line. There's a reason why there's nothing can travel faster than the light. And there's also a reason why the flame has no shadow. Ladies and gentlemen, have you ever wondered why the flame has no shadow? Well, as we all taught in school that when things are illuminated, they create shadow. A shadow is the surface area with less bright than its surrounding because something is blocking the light partially or fully from that area. However, therefore, a shadow is nothing but it is a darker surface area with the absence of light. Ladies and gentlemen, the main reason why the flame has no shadow is because the flame itself is the source of light, and also because the flame is transparent to some extent. Alright, after I show you guys experiment about fire, let me show you guys something related to the water and the light. First, get a clear plastic bottles and make a small hole right here, like this. Then fill in the bottles with waters and let the waters flow out through the hole that we made just now. Then set up a laser pointer and aim through the hole from the other side, just like this. And now you can see the light is travel through the curved stream of the water. Ladies and gentlemen, have you ever wondered how does it happen? Well, actually almost all the time when the lights of this laser is reflected, it hits every edge of the water and thus the water flows out through the water path. This light phenomenon is known as the total internal reflection. Alright. For my third experiment about light, I would like to use a beaker, some waters, and a graphic such as an arrow diagram like this. First, place the beaker in front of the diagram and measure the distance. Make sure the diagram can be clearly seen through the beaker. Then, slowly pour the water into the beaker. Ladies and gentlemen, initially the pointer is pointed to the left. But now when you see it through the beakers filled with water, it has pointed to the right. Well, actually, when the light travels through the beakers filled with water, it bends when entering the glass and the water, and it bends again when it's leaving the water and the glass. As a result, the light path cross and the image of the graphic is flipped horizontally to the right. This light phenomenon is called as refraction of light. So, next things I would like to use is some words on a paper. Well, what are these words on the paper? Maybe I should put it on the flame. Who knows, I can get some clues from that. It doesn't work. How about I put it behind the beaker? Maybe I could get some clues through here. Huh. It doesn't work too. There's a rectangular mirror. Let me check about my hair first. Sorry. Maybe I should use this mirror so that I can check out this word. Like this? No. Like this? No. I should put it like this. Now I can see the word. It's check. How about this? It's book. And how about this one? It is hide. Well, ladies and gentlemen, when I place the mirror vertically against these words and look into the corner of the words and the mirror, I can see in all of these words clearly. This is because all the image in the mirror shows that the image are actually formed behind the mirror. This light phenomenon is known as the reflection of light. However, it is only applicable for those symmetrical alphabets such as B, C, D, E, H, I, O, K, and X. With that, I'll end my science show today about light. My name is Lim Zhao. Thank you.